So I think we can start. So how it works, I am developer, not a speaker. So you can interrupt me at any time, ask questions and say, or you just say you are stupid, it doesn't work that way. I also would like to learn, that's why I'm here. And why about serverless Java? Because there's lots of misunderstanding, and I would like to tell you how I understand serverless Java and what we are doing in projects. So I still have fun with Java, so I'm backend, I'm doing 100% Java, and in front end mostly JavaScript, more than JavaScript I would say, web components. What's maybe interesting is the podcast. So had nice guests, James Gosling, Scott McNeely, even Kelsey Hightower of Kubernetes, and I've chat with with various people, because I never have time at conferences to talk to other speakers, so that's the problem. So this is the podcast, if you like, and this is maybe even more interesting to you. This is like a live streaming question and answer show, and it runs already for 8 years, over 8 years. So you only have to ask question and GitHub gist, and I will try to answer it with already the community which participates here. So it's completely free. You don't have to register, nothing. It's just fun. And there are some workshops, online workshops around the corners. I get the ideas from projects, and then I get lots of questions, can you just provide a company workshop? And my time is limited, so I try to do it online. Okay, but Discord server, also I was asked about that. Now we have one, it's called the Airhacks. It is completely free and open, public. So if you like, you can join. So Java in the clouds, you can ask me why I'm talking about Java in the clouds. It's just, why I'm not using Motorola Assembler or something different, or ADA or whatever, COBOL. And so there is a thing called Green IT, and it's getting more and more important, at least in my projects. And what Google did recently, a research, and I just copied over. So what it means is Java does extremely well. So this is what my clients are interested in, energy consumption, and if it's good for energy, it's also good for speed. So my clients are usually interested, mainly, I have to say, costs, and the second part is if it can be green, it's better, right? But there are more and more requirements regarding CO2 consumption, whatever, and if I mention Green IT, they say, okay, this is really interesting, we didn't know about that, and sometimes we have to do this. So I'm a Java developer, so this slide just tells me, we don't have to, to switch a different language. Java does extremely well. And again, you can click here on the link. This is a Google study, and see Rust, C++, ADA, which is interesting, and then Java. And if you compare it with Ruby, it is 35 times worse than Java, which is interesting, right? Okay, so about me. I started with Java in 1995, and I call it DevOps. Because what we did back then is we had to develop an e-commerce-like solution, and the project manager asked us, what do we need? So actually nothing, compiler, and asked me, you don't need a server? So I guess we need a server. And then, we wanted to buy a Sun Microsystem one, but it was too expensive, so we got HP. But we had to install everything from scratch, and we had to run it. So for us, it was DevOps. So we were completely responsible for the entire stack, except, the internet connection, which was provided by German Telekom. So actually 2 connections. So then, interestingly, in one point of time, it was forbidden to use the server, because they say, okay, there's a different department, and the different department cares about the server. So I moved to serverless. So the server walked away. There were no servers anymore in my life. I just create and packaged WAR and ears, and copied the ears to the server, to the other department, and I never saw this server again. So for me, no kidding, so maybe you already listened to my talks about Java EE. For me, the entire idea was we focus on business logic and don't care about the infrastructure. We pick, the WAR, we copy it over, and it has to work. And this is actually one of the reasons why I like, or still like, a little bit less relevant, but Java EE, J2E, and micropair, whatever, because I didn't have to learn all these servers. I just learned, the spec, and was happy for 15 years. So now the question, what do you do right now, right? So we have the cloud, what do you do about the cloud? So my expectation to the cloud is to have something we got with application servers back then. I would like to focus just on business logic, not on infrastructure, and deploy it, my business logic to the cloud. This is the main idea. Okay, serverless. What does it mean? I mean, the name is completely stupid. So this is as stupid as NoSQL. As NoSQL came out, it's like, why you are emphasizing that there's NoSQL? It's actually a bug, not a feature. And if you take a look at all NoSQL databases, they do SQL right now, because SQL is not a bad idea at all. So we have NoSQL with SQL right now. And serverless is the same. The serverless are running somewhere. And I would say the problem is maybe the name on how it was explained. What serverless means, and this not only means, to Java developers, to everyone, is we focus less on the infrastructure and more on the service. So I don't care, how to set up IP address ranges and subnets and NAT gateways and internet gateways. I would just like to create a Lambda or Azure function and just push it to the cloud. So this is what we would like to have from the cloud, because anything else we already did, for 30 years on premise. So this is the basic idea. By the way, if you have questions, just interrupt me and ask me right away. It's more fun for me, no kidding. So I'm not prepared at all, so this is always fun, to answer questions in between. At least I have an excuse. So this is a slide stolen from AWS, and what it basically means. Orange, this is what AWS does. By the way, the same slide is also available on Azure. So if you go to Azure, you will also find it. And not the same slide, they change the colors, but it is very similar. And if you go here, this is also similar. What it means is this is the boring on-premise infrastructure, and this is serverless. What it just means is is more orange, and blue are we. So less blue is good. This is serverless. It means I don't like to play with operating systems now in 2023, and I don't like to pick a open JDK and do a research which JDK is the best. I would like just to run Java C and run the code. So this is how I started with Java. I started with Java without researching JDKs, operating systems, and Docker images. We just build the code. And now maybe we have the chance to do it again. Okay, so serverless. The most important thing is number 3. Is invoice profiling. It's not important for us, it is more important for management. The invoice looks differently for serverless applications, because usually they will see how often a service is called. And pay-per-use means, if we have an order system and we order a car, a Volvo, 10 times, and the invocation costs €5, and Volvo costs, let's say, 5,000 euros at least, right? So there is a margin there. So, and if this pays off, it's okay. But if we write a log statement, and the invocation costs, €5, something goes wrong, because we cannot pay, for logs. So what it means is, what we get, if we do it right, we see, how expensive our use cases are, and if they are less expensive than the margin, everyone is happy. So what's the problem with, I don't know, application servers, Kubernetes, and all the other stuff? If you have, let's say, application servers with multiple wars, they share, the business logic, and no one knows how much use cases were consumed by, how often use cases were invoked by what client. And it is impossible to tell who should pay how much. You are just pay the entire month for the entire thing. And this becomes, in my project, less and less acceptable. Management pings me and say, hey, look, we are paying 6,000 euros for a Kubernetes cluster. What is running inside? So, okay, look, we have to install additional open source tools to find out what happens inside. So that's the story, right? Okay, for me, very important from security perspective, less responsibilities, Docker layers, operating systems, faster provisioning. So what it means is, when I prepared here, I have here, I did it in advance, and a Fargate cluster, and I really like Fargate. This is like, productive and lean Kubernetes. And it could be even sold as serverless, because I don't have, to buy the machine, I only focus on CPU. But first, take a look on Quarkus. This is stock Quarkus, but what Quarkus ships with, source, main, Docker, this. Quarkus ships with a Docker file, and it inherits from OpenJDK 17.1.14. So if they change the version, maybe they could introduce a security risk, which actually happened in my project. So this is not a problem. I mean, this is a fact. If you're inheriting from an operating system, you have to scan it. Even worse, some teams are using this, other teams are using Distroless, then Alpine Linux or Red Hat Enterprise Linux. The problem is we have to think, this is the first question, from which operating system should we inherit our Docker file? So this is an unsolved problem because in all my code reviews I see 5 teams, 5 Docker files. Somehow it's really hard to standardize this, but it could be standardized once and never again. Never happens, or it very rarely happens, right? So the next question is, which Java we are using here? Is it patch or not patch? What happens on log4j or whatever? So this is questions we have to answer to management. It's not like, I challenge you. This is just a fact that we have to do something about that. So what I don't like to see is this in my project, right? Anything else is actually pretty great. So we have a Jakarta EE or JavaX. This is what I had for years. In fact, I recorded a talk 10 years ago about Java EE, and now I package this as Lambda. It still works. No migration, so it's great. So we have a health probes. We could use it, of course. It is used by the, you see, I refactored that 2 days ago. So the probes is in health checks important not only for Kubernetes, it's also important for Fargate and for Azure App Service and all other container orchestrators. And this what happens behind the scenes. And now take a look at the infrastructure. So maybe I show you how the Java code look like, and then we can even look at the console. And by the way, I listened also on the previous talk, it was also good, to questions regarding CI/CD. So in my current project, we are assuming there is no access to AWS console, so you cannot open the console, and there are no manual changes in production, so everything runs from CI/CD. This is what we do. We always start with CI/CD pipeline, we push to GitHub or Bitbucket, and then everything is built. And on AWS, we use code build and code pipeline for it, for instance. So it's also serverless, so you only pay if it runs, and if you run it all the time, I don't tell you a number, but the price is really okay. So, so this is the infrastructure from the Fargate. This is I just rewrote the code not to violate NDAs. So this is a green room implementation. So okay, I can show something at conference. And so this is also Java. The question before was, how do we deal with templates? And I said, okay, how we deal with templates? And I said, okay, we defined all infrastructure with Java. The template, the use of templates is jar in Nexus. So what we do is, if something is working, we push the infrastructure to Nexus, then download it and run it. And this is versioned for years. This is what Java developers doing for 20 years. And so there is actually no way to change reusable piece of codes in the template. So, and of course, you could share Java, the source code here, but this would be larger projects, I would say, a little bit problematic. So there is a greetings, and this is the same structure I did for years. So we have here configuration, the task configuration, and this is just the key value pairs, which are then passed to the task. And could be read, from whatever you like. We have ECR, and this is the first thing. In order to deploy on Fargate, I have to care about ECR registry. So this is ECR registry with repository in order to push it. So the first question is, do we really need it, right? So I would like just to have hello world. Why I have to create ECR registry first? So then we have the ECS cluster, and this is a little bit unfair because I used the already available construct, and what you can see here, I have to create, and this is actually nothing new. If you start with a cloud, you have to start with VPC subnets. Usually you get 2 subnets per availability zones. There is a NAT between, you have internet gateways. I would say, if you never did it, you will spend 1 week just playing with IP addresses, and then at the end, maybe you manage, to deploy your first service from scratch. Of course, if you download something from internet or ask ChatGPT, maybe it will work, but no one will know why, right? Any questions? You are very quiet here. Everyone is with me, so you're already running the entire infrastructure with Java and never had any problems, right? So, okay, so what happens here? I'm creating a VPC from scratch, and the name is wrong. It shouldn't be OIDC. It was a proof of concept. I wanted to call it Code Europe, but forgot about that. So OIDC. And you see, I'm also cheating. I only have 2 subnets with IP mask 28. And usually I will have, 3 subnets and public and private, because you have, for security reasons, you would like to have public, services in the front and something private like databases in the backend. Okay, then I have a container image, and I would like to pick the container image from the registry. And then I also cheated. I used the already available construct, which is greatly simplified, but I'm just saying I would like to have a half a CPU, one task. This is the health checks is performed, and memo limit is 1 gig. And I would like to configure the load balancer checks. So this is here. You see I'm using Quarkus Q Health. And so I'm also picking the service. I'm saying, okay, please don't start the service yet, because the ECR registry is empty. And with one, how much is it? Oh, now this is the task definition itself. This is like the Kubernetes Helm chart, is this one. What it says is, this is the health check, and the name of the container. So this is the container image, and please run it. So with 200 lines of code, you have the entire Fargate cluster up and running. In one project, they use several thousand lines of Terraform code. So this is, the power of language. We have for loops on if statements, it works properly. And what I showed you right now, it is just for the demo. Usually what we will do, we will create a task definition, create a jar, and externalize it, so you won't see the code here. So I expanded the entire code to one class, so you see everything in one place. Where I am going with it is actually lots of plumbing, and no one is interested in it, right? No startup is interested in IP addresses, ranges, or ECR registry. So what we could do with Quarkus, for instance, how really a serverless solution would look like. And so I would like to do it from scratch, and the only reason why I didn't wanted to do this from scratch is because it takes like 5 minutes to deploy the entire infrastructure. Set up Quarkus Lambda, and now Dragon is a good name. This is the fellow. So, by the way, it is no magic. You can clone it from GitHub. This is what I'm using right now, and it just cloned this from GitHub. This is exactly the same. And I updated this last month for Java 17. Okay, so what happens here? Go to Dragon and run and open it with Visual Studio Code. It already opened that. Okay, this is too much. So again, run it, open. So what we have here, we have the CDK, and we have here the Lambda, and the system tests, which is irrelevant here, but in projects, everything is tested from outside. Okay, the CDK, how it looks like. So what we basically have here, it is the most complicated Lambda, because I can switch between API gateway, function URL, and application load balancer. And today I show you the simplest possible solution, which is function URL here. So the function URL is just Java class, and this basically it. What it says is, I would like to have a new Quarkus Lambda. And the Quarkus Lambda defines the Lambda, no IP addresses, no NAT gateways. The only thing is this. This is the difference. Dockerfile does not exist. I'm just saying to AWS, and Azure Functions is basically very similar. So there's not like AWS technology. So with Azure Functions, you get very similar experience. So you say runtime Java 17. Architecture now depends. If I have snap start, which is a new optimization based or similar to crack, this is called coordinated resource at checkpoint. So the first time, coordinated resource at checkpoint. So if I enable snap start, is only available right now on Intel, usually running on ARM. Why ARM? 10% less cost, more energy efficient, and sometimes or often 10% faster than Intel, and Java doesn't care. The cool story is runtime Java 17. No discussion. My current projects, they wanted to audit our environment, and the cool story was there was nothing to audit, because AWS patches, the JDK for us, so there was actually nothing to do. And Java 17 means the recent OpenJDK corrector, which you can also download, is automatically patched by AWS. No Docker files, no operating system, nothing. And then I say I would like to pick function.zip, and this is as what I told you before, 1995 Java C code, just business logic, nothing else. So, and the cool story is, a question I get often, how we test serverless applications locally. And the cool story is, Quarkus doesn't care. So what I can do is, I can switch to Quarkus, Dragon, Lambda, sorry. This time it is Quarkus in the role of Lambda, and say Quarkus dev. And hopefully, no Quarkus is running. So, and this runs my Quarkus locally. And with a little bit of luck, I can say localhost 8080/hello. And this is Quarkus on AWS. And I could also say, wait a sec, where is the code? This is CDK, Lambda. And by the way, it's still my old Java E code, right? Oh, this is older. It was not, I could migrate it to this recent one. It would be Java Jakarta, not Java X, but it doesn't matter. So it's exactly the same code. Actually, it's cool because you see on Fargate, I updated the example to 2 days ago and migrated to Jakarta E, and this is the older code. So as you can see, this is no Lambda, no dependency on AWS. And so if I change, the greetings on Dragons. So this should actually work on Dragons, right? So, and now the question is how to push it to AWS. So what we usually do, we just use Maven because all companies use Maven. And so far, don't ask. I'll show you, this is the entire script. It builds with Maven the first package, then it builds the second package with Maven, and then it uses CDK deploy all, require approval never. And this is important because if non-serverless deployments take longer, and then I can pick a coffee. This, without this require approval never, it will ask me, should I really deploy? Say yes. So this is like, so build and deploy, don't ask. And maybe with a little bit of luck, oh, there was an update happens, it could even work. So, questions. So I show you now two possibilities, and we still have time. This is just questions in between. And I have some slides, so don't worry, I have enough content, but now it's time to ask questions because it is completely code deployment from scratch, and maybe I could show you in my account how it looks like. So before we had the ECS Fargate, so it runs here. This is the Fargate service with, this is the health check was, and this Fargate runs on a, where is it, a load balancer somewhere. This is the load balancers. On this load balancer, the load balancer runs in a VPC. This is the resolution is a bit low. So this is, it runs in this VPC in 2 availability zones, and this is the application. And it was created 2 days ago because I wanted to have it running here. So it runs for 2 days, this Fargate cluster. And still, it is serverless, but I had to do a lot. I mean, with Java less, but try to do it from scratch. Let's take Terraform and just create everything from scratch. You will spend at least a weekend. I mean, if you did it before, right? And this is what you will do. Will be not multi-user capable because you will have to share the state, in the cloud somewhere. So, okay, so let's see. Yeah, sure. This is why I'm using the stock CDK. I'm using stock CDK. The question is it CDK, Cloud Development Kit? Yes. I'm using, my idea is, try to use the cloud as much as possible and have as simple infrastructure as possible. On AWS, we're using CDK and an Azure Bicep.
Yeah, I know, for example, there's also a project called Pulumi, and it has also Java bindings, so that would be...
Pulumi is great. I also had the founder on my podcast. I really like the idea. The problem is, imagine a large company, asking me to do something with them. And I suggest Pulumi, I have to justify why Pulumi. But if they come to me and say, hey, we have AWS, I never had to justify CDK because it comes with, this is exactly your Red Hat. if back then companies had, Red Hat contracts, I never had to justify why we use Whitefly or Quarkus, because it is not natural to them, because there's already business relation with the company. So, and if you are a Pulumi, I always ask my question, what happens if a large company buys Pulumi? Right, so it happened a lot in the recent years that infrastructure companies are bought. So this is interesting thought experiment. So the idea is with CDK, we have Java support, Java developers love it, and it's officially supported by AWS. And if my client's running AWS, no questions left. So this is my thinking, right? So it doesn't have to be cool, it has to be secure, automatically patched, and officially supported. And no discussions, otherwise I would spend 80% of my time in meetings. It's really dangerous, such stuff. But what I wanted to show you here is the first cold start without snap start, the smallest, the slowest possible invocation you can currently get, basically Java E code as Lambda, as fed Lambda. So in Frankfurt it's running right now, and it was completely cold start, 3.2 seconds. With snap start would be 1 second, and if we run it now, it is, network is okay, 100 milliseconds if it's warm. So you get the experience. So what I do right now in my projects, everything is serverless, and we're building fed Lambda. So monolith, hundreds of classes, packaged with Quarkus, on the one Lambda, very simple and cost effective. Thank you for the questions. Other questions? If you ask questions, you get a pencil or sticker or something, you get a full bag of goodies, so I have to give it away because it's heavy. So any other questions? Very quiet room. So then some slides. So less responsibilities. I hope you saw the contrast. I like Fargate a lot. We run Fargate for economical reasons. Sometimes Lambda is more expensive than Fargate, for instance. Then we use Fargate. But Kubernetes, Fargate, or Docker containers is not necessary to place to start, especially not for enterprise applications. They are running from 8 to 5, and then nothing happens at night. So with Lambda, it's just perfect for that, right? So faster provisioning, I would say it was 3-4 times faster than the entire Fargate. And this is also connectionless managed services. Also, this is, maybe it goes too deep, but if there are no questions, we can cover this. So if you have a serverless service, what it means is we have multiple processes, not multiple threads. There will be a slide. So what it means by that, there can be problems with connection pooling. Actually, there are problems with connection poolings, and I show you how to solve them in a later slide. If I forget it, challenge me and say, hey, we forgot something. Serverless. So what means for me, if there is a VPC, it means a network is already a bad sign about serverless, because it means you already know you need IP addresses, you need machines. So no VPCs, subnets, and IP addresses, less code to write, for sure. I mean, business code in Quarkus is identical in both cases, but infrastructure code. What serverless is interesting, in my eyes, is more secure because you are accessing the services via HTTP, and every call is guarded with a permission, so you have more possibilities. Where if you access, a database via JDBC or Kafka, it is a binary protocol. You have to implement the security inside Kafka. This is what I mean by that, okay? Built-in authentication. So this is what you will curse, with clouds the second time. Roles and permissions. I don't know whether you tried to do something with the cloud. So if you get, an error, error for 403 or 1, so permission error, what usually means you forgot a role, to set up a role. And what we see then is developers say, okay, then I run as an admin, but this is the beginning of the end, right? So and if you don't run as an admin, it is significant. What I forgot to tell you, with the CDK, if the Lambda would access an S3 bucket, the roles would be automatically set up by AWS. They are sometimes too broad, so we are still, we go with it in the first iteration, then we look at the roles and say, okay, we can still, delete this. The permissions are too broad. We can still, delete these permissions, but it's a very good start. So you don't have to fiddle, with roles and whatever. So it's actually really productive environment, and it really reminds me on J2E or Java E back then. So high automation. This is also a very important topic. This is the last one. So if we are using Cosmos DB or DynamoDB, let's say, what I can do with CDK, I can create a table during provisioning. If I'm running Postgres, I have to wait, half an hour to get a Postgres instance, which is basically empty without any permissions, without any tables. So what it means is if you have managed services, you can automate the resources as business objects. Okay, this was just Lambda. I also heard, Lambda is not secure. Truth is, Lambda is more secure because it runs in kind of a virtual machine and it's restarted, so nothing is shared. You could hack a Docker container, one Docker container, in theory, access another one, but with Lambda is harder because nothing is shared. And this is important in some of my projects because of security audits, and Lambda is currently, I would say, I don't know whether it's the most secure platform, but it looks like. So I don't know to compare to what, but because of that, it is maybe the highest isolated platform, maybe this way. So security. So we have infrastructure as code, state, secrets, everything are just Java classes. So we just code this. Everything is defined in Java. And this is also fun. For security audits or code review, we can pass the Java code because if no one never clicked in the AWS console, there is no reason to look at the AWS console. And the only exception from the rule is DNS. This is what really makes me angry because DNS can be only available once and sometimes you have to create it manually, which is, maybe this is even better because sometimes you have to recreate the entire infrastructure and recreating DNS names is maybe problematic because you have to wait 5 minutes until it propagates, but DNS is the only remaining problem, I would say. Okay, incremental improvement, deployment, sharing. Yeah, this is, I could just repeat, my infrastructure would just work because it's not like APIs are called. It's more like the state is submitted to the cloud and the cloud, calculates the diff and applies the changes. This is what Kubernetes also does with the reconciliation loop. Okay, so on-premise, so I would say, I'm not about cloud, I would say on-premise, also great. On-premise, I will pick an Kubernetes distribution like OpenShift, I like a lot. Or Rancher, and you have completely different possibilities on premise. So I would say on premise, complete different story. Doing serverless on premise is a little bit strange because it would imply you have no spare hardware lying around. So I would say on premise, Kubernetes like OpenShift makes perfect sense. It's really convenient. I use OpenShift a lot. And in the cloud, Kubernetes makes less sense for typical enterprise business applications. This is my observation. At least I don't see, the major advantages because what you need in the cloud is either a serverless solution or something which stops and starts Docker images. It doesn't have to be Kubernetes. So Docker is actually the API, not Kubernetes. At least my observation. But if you see, you have counter arguments, let's talk. But you are very quiet. So this is, I'm actually, so I try to provoke you, but it doesn't work. So this is somehow strange, right? What I can tell you even worse. So like, let's see. Now I have to think. So the price structure completely different. This is interesting. On premise is like I have to think to make it right. So on cloud is the storage extremely cheap and CPU is extremely expensive. On premise is often the other way around. There is no storage, but you can get some CPU. And if you get the CPU, it is free. So this is actually the difference. And what it means is relational databases, if you think about this, make absolute sense on premise, but absolute no sense in longer term in the clouds because they are optimized for storage. Yeah, think about normalization. Just talking about costs right now. So automation is hard on premise or not even possible. There are no APIs, except if I have OpenShift, of course, then I could automate a lot, but without OpenShift is harder. So I saw a lot root access, right? All Docker images running as root, and then they complained that OpenShift doesn't accept the images, and then was a hack. I forgot this. There was an OpenShift extension to allow root. What's the name? You are from Red Hat. I forgot. There was an extension, How? Yeah, any ID, exactly. This any ID, this is an absolute hack on premise. In cloud, such a thing wouldn't be even possible. You cannot go to Azure or AWS and say, I would like to be a root. They say, but we don't like this, right? So this would be the answer. So always on and, intra-department dependencies. What it means is, for instance, if I'm working on premise and I have to create a certificate, I'm already, saying, okay, oh no, I try to postpone it. I have to, to send an email, wait for the answer, and hope everything done right. In the cloud, it's just API call, for instance. So the evolution, very quickly. This is how I started. So we had, an application server with lots of applications. The next step was, okay, we modernized this, container CDI and Jakarta application server. Then we said, okay, actually, we have microprofile on Docker. And what I showed you today, the only difference is I swapped Docker with Lambda. This is the only difference. And this is actually what happened today. We have one application with one Quarkus Lambda, and we use exactly the same code as 10 years before, which is actually cool for bigger clients, because one of my recurring question is how we migrate the code to the cloud. And it's okay, we can actually pick, a whitefly code, put it to Quarkus, and just run it as serverless. And we overtake anyone else because of the cost structure. So what we can do actually, what this example is about, we have self-provisioned runtime. I could run the same example on bare metal, which I did today to show you and I also did the Lambda. What I skipped is the Docker, but I did it on Fargate. So I could have exactly the same code running in serverless mode, running as bare metal, and running as on Docker, depending on the load and cost structure. That's the idea. Okay, for Java developers, what's the difference between application servers or Spring Boot or whatever you have, and a serverless environment? So on application servers, we had threads, and on Lambda, everything is a process. So something like request scoped doesn't make sense. It works, but it doesn't make any sense. So on Lambda, everything is application scoped, and all these scopes don't make sense because for you, it looks like the Lambda is started and shut down, and if it's warm, there can be never two threads in one Lambda, which is identical to EJB behavior, by the way. So if you like EJBs, you are the best serverless developer right now. So this is actually the great, thing from legacy enterprise developer to cool serverless developer. Now is the opportunity to show you expertise because it's exactly the same ideas. For instance, min pool size to keep the EJBs warm. In Lambda, we have provision concurrency to keep the Lambdas warm. There's a max concurrency in Lambda, we had max pool size. It's exactly the same principles, just the parameters a little bit different. So if you have the knowledge, just use it. Okay, now this, can I just make it larger? So this is, I get the question a lot, how expensive is it? So this is a calculation for Frankfurt. This is just a screenshot. And this is ARM architecture. I'm running 2 requests per second, the entire month, night and day. The average duration is 100 milliseconds. This was 150, but the calculation is wrong. The calculation means inside the Lambda container. What I showed you right now was the round trip, from my machine to AWS to the Lambda. So it was a lot faster. We can actually take a look how fast it was. But wait a sec. I have to complete this. As you can see, I'm not a speaker because I'm too chaotic. But this means with 1 gigabyte of RAM. So the question is why we dedicate to Quarkus 1 gigabyte of RAM. Who knows? It's crazy. Quarkus needs 90 megs of RAM, and I'm running 1 gig. Who knows that? Because it is the most efficient and cost-effective configuration. With I would say 2 gigs of RAM would be even better. With 2 gigs of RAM, you get entire CPU. You only can buy CPUs with RAM. And if I would run Quarkus with 128 megs of RAM, Quarkus would be happy. The problem is you get 1/13 of a CPU, and Java will start 20 seconds, and you will have to pay for it. So on Java, dedicate on Lambdas 1-2 gigs of RAM, most cost-effective and fast configuration, and we would pay 8 euros a month from the entire setup. But for enterprise applications, think about this. It is really hard to have an enterprise application with 2 transactions per second, 24/7. Yeah, this is minor. Just showing you, this is no optimization here, right? Just showing you what you can achieve with simple code. And if you optimize, we get 20% better. But now we are already overtaking, most of the projects with almost no code. This is actually the idea. Now about the performance. CloudWatch. Wait a sec, maybe another possibility here. CloudWatch. And we have here Dragon. Is there somewhere with Dragon? I cannot see the Dragon because in the Dragon, Lambda greetings. This was not Dragon. This should be right. 12. This is our time. So you see, this is stock Quarkus. Wait a sec. I forgot. You see, this is the invocation time. So this was the startup time of 400 milliseconds, and we would pay for 5 milliseconds. This is build duration. Sorry, there will be. I don't see build duration here for 400 milliseconds with 1 gig. So this is what you will charge for. My calculation was 100 milliseconds. Of course, if I will call database, it will be slower, right? So I'm just showing you how fast Java as Lambda actually is. Okay, so this was the log files, and I didn't want it to connect to my AWS console because maybe you will see something, right? So, questions about that? So do you see the logs? By the way, the CloudWatch log groups was automatically created by the CDK, convention of a configuration. We know what the name of the service is, so we create everything from scratch, and the convention is captured in a jar. Jar is pushed to Nexus. Other team member just pulls this to Maven and works, it's just working out of the box. Okay, these were about the costs. What it means is, in Lambda, serverless, what we get with it is, we get the unique opportunity, the first time, that every developer can get production-like environment. Because it doesn't cost you anything. So what you do, every developer gets an account with full setup with Lambda, and then she or he will really have to work hard, to have 2 transactions per second the entire month, and then we will pay 8 euros. With Fargate, it's harder. So, for instance, I was too lazy. My Fargate runs all the time right now, and I spent already maybe 20, 30 euros. So with Fargate, you will have to shut it down at night. The NAT gateways, you will still have to pay for it. But in serverless, there is nothing actually. This is a perfect environment. I would say not the future is now, but every developer gets an environment which is identical to production, not production-like. This is identical, no difference. Okay. Okay, this is a screenshot. I thought I am in the console. So we saw that. This was also the code. Some references. For instance, saving costs with pragmatic serverless Java architecture. You've searched for it. And hey, enterprise EJB developers, now is the time to go serverless. This was also fun recording. I just used EJBs to explain lambdas because it works very, very similarly with the same. Even if you know the programming restrictions of EJBs, you can directly apply it to all serverless environments. And this basically was. So I would say clouds are not necessary actually. So you can stay on premise and be really happy and even have advantage over other companies who do lift and shift, which I don't completely understand why it happens. And if other company makes lift and shift to the cloud and you stay on premise and you're happy with the data center, maybe you even have a business advantage. But if you go to the cloud, then use the cloud really, and then you saw what's possible with a little Java code without almost no changes to the existing Java code. What I forgot was the state management. You are very quiet. The problem we have right now, if this were a Quarkus and we would access Postgres database, it would still work. But we would get 3 connection pools concurrently, right? Because one connection pool, another connection pool, another connection pool, 3 JDBC connection pools. And if you have 1,000 lambdas, we have 1,000 connection pools, and if every connection pool has 50 connections, so we would get 50,000 JDBC connections, which would be really bad for the database. So the problem is, the older databases and resources, Kafka has the same problem, you need a pool or a connection. Managed resources like Cosmos DB, Kinesis, SQS, SNS, DynamoDB are connectionless. You are using HTTP. So if I would access from Quarkus a 3 bucket, there is nothing to pull. It's just the HTTP connection. You should also think about that, which resources to choose. And what I usually get from developers, they tell me, okay, but then I am completely dependent on the cloud. I say, okay, but there are two possibilities. No, what's about the dependence, yeah? What does it mean to be dependent on the cloud? You can be dependent on the cloud if you can quickly switch between clouds. So you have two choices. Either you abstract everything, so you are running on AWS, but you don't know that you are running on AWS. The question is, how long will it take to understand and maintain such a system? Or you go, full power to AWS on Fargate, let's say, and write simple code. And if you have to switch to Azure App Service is very similar to Fargate. So then you will just edit 30 lines of JSON and it's migrated. So, and I believe more in simplicity than abstractions. We tried to abstract in Java for 30 years, almost, or 25 years at least, and it's not always worked, I would say, this way, right? So, now we covered the connectionless and managed stuff, and yeah, I'm also running my own servers. I still enjoy servers, no problem. In the cloud, when I have to do something, it's always serverless. And forgot also something, if you start up fresh projects, always start in AWS Calculator, for instance, to give a rough idea how much does it cost. And if you have the rough idea, to quickly estimate the costs, build a prototype, run it for 2 days, and you see how much it will cost. So this is at least my approach, and it worked well so far. So and if you go to the cloud, use the cloud, not say, lift and shift, I was just launching a virtual machine on Azure, and now I'm cloud native, right? So yeah, if you like the workshops, you can join the workshops, still a few seats free, and thank you. You are very quiet, so the speakers were no more chatty than you. So
on one of the slides you showed, you talk about that on premise, essentially, if you use Kubernetes, there's no automation basically, but you probably could write operator, right? And also in Java as well.
Yeah, but no one will do it in larger companies. So what I like on OpenShift, for instance, I know we're from Red Hat, but really, the commands were nicer than plain Kubernetes command. So the OC, I think, right? Who has OC back then? OC? CLI, OC, exactly. And what I also liked in OpenShift is it was opinionated Kubernetes. You get the ingress controller, you get the Docker registry, your identity management everything was in place. What I don't understand, why a company would run on Kubernetes. The days are over where they are recompiling Linux kernel. Also we pick the distribution and go for it, right? So this is too much plumbing. Of course, there are cases if you are running, YouTube or whatever, this could make sense to run, your own distribution, but we are not YouTube. So what it means is, in OpenShift, we automated a lot. For instance, what I really liked in OpenShift was the built-in Jenkins. So the identity, everything was solved. We created a pipeline, and we even had a Jenkins who provisioned other Jenkins. So everything was automated, but we had the API. But for instance, if you take away the Jenkins and you have plain Kubernetes, you will have to do something, And now the discussion starts. What you should use, Argo, CD, or Tecton, or Jenkins, and then we can already plan 5 days meetings just to discuss which solution to evaluate. And why we should evaluate again, just pick one and run for it, right? And in the cloud, everything is set up. On premise, if you would do this, in a project starts, who is in charge of the automation, right? Or a single project or the entire platform team? If you're a platform team, how pragmatic is the solution, what they are delivering? Are the developers happy with the solution? Lots of challenges, I would say. Okay, so I have 1 minute to go. Who can ask at least one question? Someone else? Was too obvious, maybe. So next time I will do a different topic. Yeah, here is a question. Very good.
You mentioned a cost over the lambdas, but you haven't mentioned API gateway cost because you have to use it for lambda calls, and the cost is kind of $1 per million requests. So
there are two API gateways, Calculator, AWS. One is the REST API gateway, and there is an HTTP API gateway. Using the HTTP API gateway, and this is I think 10 times cheaper. and the older one is more powerful, but is expensive, but is really old one. So, and we can create the estimate. We have 16 seconds to go, it will be tough, but create estimate and region Frankfurt. This is what I usually doing. This is API gateway, configure, and you have to help me. So we have per second 2 invocations. This cannot be millions. Do quick math, 2 transactions per second. How much is it? No?
Yeah, I wanted to ask regarding the also
per second.
If I have a million.
Oh, 2 transactions per second. Exact number, $6. So you are right. It will be $14, not 8.
Yeah, but if I have million calls per day.
There are two transactions per second. It's the same calculation. The entire month, day and night. And of course, this was marginal costs. 200. No, it's 100 times more. Pay what you use. 200 transactions per second the entire month, you will pay 600 euros or dollars.
And what if I compare cost if I use, for example, Kubernetes on this AWS EKS?
Oh, Kubernetes, you will pay roughly $90 just for the control plane.
For the cluster, yeah?
Just for the cluster without starting anything. And then you will need for Raspberry Pi per month, you pay at least 80 euros for a machine. This is like Raspberry Pi power. In Lambdas, 2 transactions per second means we get 2 cores at the same time and 2 gigs of RAM. If I specify 10 transactions per second, it would be 10 cores and 10 gigs of RAM. So Lambdas, it scales like crazy, right? So because we get the entire core for the method invocation. In Kubernetes, you get 2 cores or 4, whatever you buy, for all the threads, not for one invocation.
Yeah, but why are you bounded to just 2 transactions per second? Like
because because I did it 2 transactions per second in the Lambda as well. So the same calculation. You mean now there are 200 transactions per second?
Okay.
I could do 300, but it really depends on your use case.
Yeah, but what if we have, for example, 100 millions requests?
Yeah, this is what I told you. If you have millions of transactions per second, then forget serverless.
No, not millions per second, but for example, 100 millions per day.
This would be even interesting, because Lambda is very good in scale up and scale down, so it could be still cheaper. What I would like to tell you very clearly is, in one point of time, serverless is a lot more expensive than non-serverless. It's not like, serverless. This is a trick what I showed you. I tricked you because what I told you, enterprise systems, they are not YouTube. It's not like you get, 500 transactions per second all the time. There is peaks and downs. Launch, nothing happens. Night, nothing happens. So this is why my trick with 2 transactions per second, because it's a lot, because it means, a day maybe you have peak with million of transaction, and at night nothing. At night, nothing, This was the trick. But if you already know you are building the next YouTube, I wouldn't use Lambda. So what would be the choice? I would look at EC2 with Spot instances, for instance. But then I will have to build my own scheduler. I could do this, but for enterprise projects, why, right?
Okay, thank you.
We can talk, for me it is clear, so we can talk about, and by the way, API gateway you don't have to use, you can use load balancer with Lambda as well. You can use function URL without the load balancer, this is what I used, then without API gateway. So there's API gateway v1, v2, load balancer, and function URL. Any other questions or suggestions? Okay, cool. So at least we've wrote some code at Code Europe. My time is over, and see you in Warsaw. I just would like, to change the presentation to be more high level because I hate to do the same thing twice. So in Warsaw will be similar topic, but a little bit more extended. So thank you, and maybe see you next year.